Alright, hi everybody. In this lecture we are going to do a quick look at 6 different scripts. I've chosen these 6 scripts because they are, most of them have to do with loops, and they are very important for completing our first programming assignment. They illustrate lots of different principles about redirecting data and reading through loops and reading information when you don't know how many elements are on a given line. We will take a look at read loop. The purpose of read loop is that we're going to read each line in a file and echo it back out. And we don't know how many lines are in the file, but this loop takes care of that. So first we'll cat it out and then we'll run it. So what our read loop does is it has first all our shebang line, and then the next line is while read my line. Now we haven't talked about the read command yet, but what read does is it grabs a line of text from the input, so it reads until it hits a new line character, and then it returns that and stuffs it into the variable which is its first argument. So you give it input via standard in, and then it takes its output for when it extracts a certain line and it stuffs it into the myLine variable, in this case, whatever this next argument is. So the return value of read is 0 if it was successfully able to read a line. If it was not able to read a line, then it'll return a 1. What that means is that this while loop will continue running while it's successfully able to read each line, and it automatically moves through each line, discarding it as it goes, so it is processing its way through the whole thing. So in this case, what all that this loop does is as it reads each line out of myLine, it then echoes myLine back out. So remember, each line is stuffed in its entirety into the variable myLine. So to get it back out, we echo $myLine to see the contents. And down here is the magic. So we have do and done that surround our loop, but we are redirecting the input from the first parameter, get the value of that first parameter, and then redirect that as a file. So open up the file specified by this first parameter, and then redirect that as standard in into our loop, which is where read gets the data from. So somewhat confusingly, the data that we're inputting into this loop is not specified up on the top line. It's specified on the last line, specified as the last part of the last line. So let's see how it works. In the next line, in the next command prompt line here, I say read loop, which is the name of our program. I pass in the name of a file. So what read loop does is it starts into its loop and says while read myLine, and it is able to scan ahead to where the done is, and it takes this one positional parameter which refers to the first parameter of the read loop program that was just run. So the first parameter contains the text test file. So $, get that value out, get that test file, and then this operator, the open for standard input operator, looks for a file with that name, finds the file, loads it in as standard in, and then that is where the while loop is going to grab its data from as it passes each line through the read command. Each line is then read and then output, and we can see that here. Here's all the numbers from that file. Each successive number, 5-number sequence is a separate line read out from the file and displayed on the screen. So this works great for getting an indeterminate number of lines from a file. So next, let's look at the array loop. Well, one way of looking at an array loop. Now, I don't recommend that you use arrays in, for example, program 1. They're very complicated. The syntax is weird. First of all, we're going to define a whole new operator that we haven't seen before. So here's our function, our program. It's called cat array loop, and the first line of our script is the shebang line, and then we're going to define an array. And in this particular one, we use parentheses and then our text values in the middle, 1, 2, and 3. Our for loop then starts out by saying for I. So we know that I is going to be the variable that holds all of the values that we're about to stuff into it, and the contents of our loop simply echo all the contents of whatever I is. So what are the values that we're going to stuff into I? Well, in double quotes here, is going to be where those values come from. And we have to use $curly brace when we're expanding the contents of an array that we want to read from. And when we use the @ symbol, we're saying get all of the elements of the array and expand them out from this $curly brace operator and replace this whole thing with each element from the array. So the effect is that this essentially says for I in quotes 1, 2, 3, end quote. So from the perspective of the for line, it doesn't have any idea how much is in the array. We specified that before. And down below we see the result of this. If I run array loop, it simply prints out 1, 2, 3. In this kind of simple example, we can see all the different operators that come into play to work with these arrays. And as you look around online for additional syntax examples, you'll find that it's a deep rabbit hole. So again, I don't recommend them. It's not really something that we talk about in the course. We don't really need the arrays, so your mileage is going to vary with these things. Our next one is the for loop. And the for loops, or this particular program here, is we're going to manipulate each number on a line when we don't know the length of that line. So before, in our read loop, we were looking at a file of an indeterminate number of lines. Now we're looking at a line of an indeterminate number of entries on that line. So first we set up a variable called oneLine, and oneLine is going to have a number and then a tab, a number and then a tab, number, tab, all the way out. And we could have used spaces in here too, but I used tabs just to show you that for can also work with tabs. Then we say for I in $oneLine. So get the value of oneLine and stuff it into here. Then the for loop will automatically process through each entry in that variable. So when we say echo I is and then $I, we're able to display the contents of that as it goes through. So really handy. We can use these for loops and a variable that contains a bunch of tab delimited numbers as a way to step through every entry in that line. You'll do something similar to this in program 1. Now let's look at sum loop. So what sum loop does is it's going to sum up the numbers in a file where that file consists of just one number per line. So a little bit more complicated here, but so we're enforcing a structure for the file that this particular loop is going to use. So cat sum loop, here's our shebang line. Start with a sum variable. We'll set it equal to 0 at the beginning, and then we're going to create a temporary or a variable that holds a string that looks like it refers to a temporary file. So this variable is called temp1, and we're setting it equal to the string ./tempfile. Then we have an echo statement. So echo -e says that implies that we're about to have an argument that consists of new lines, and sure enough that's what we have. So the actual argument that we're outputting is going to be 8 new line 7 new line 6. Take that whole thing, dump it into a file that is contained in the variable temp1. So then the actual contents of temp1 are extracted with that $sign operator. That is written into this spot, and this line is then echoed into the file called tempfile. Alright, then we hit our while loop up. So our while loop is going to read, and every individual line that it reads out of this loop is going to be stuffed into the num variable. And the data for this loop is going to come from a file. We can tell that because here's our standard in redirect operator, which means it's looking for a file that it's going to grab, that it's going to open up and extract the data from. And the file name is going to be contained inside the variable temp1. So take the temp1 variable, use the $sign operator to extract the contents of temp1, and that gives us ./tempfile. That is the file that is going to be opened up by this redirection operator with its contents stuffed in as standard in into this while read loop. Alright, so the contents of the read loop, what's it doing of our while loop here? First it's going to echo out that it's in the loop, and at the end it echoes out that it's at the end of the loop. And that's important. These are trace statements that help display in the output what your program is doing as it's going. And we can see in that output on the right side, we can see in loop, end of loop, in loop, end of loop, in loop, end of loop. Really handy so you can track what's going on when you're trying to debug a situation later. Then we output, after saying in loop, we say, all right, the value of num is this. So here we're using another trace statement to say this is what the variable num consists of. Then we're going to start adding things up. Our sum value started at 0. We're going to use a subshell, note the backticks, and we're going to use the expression command to add up whatever sum was before with whatever the number was that we just read in. So remember, num is the value read in by the read command, and it's the entire line that came from that file. But since we enforced that each line is only a certain number, or is only a single number, then this will work just fine. So the expression is going to add together, the expression command adds these two numbers together. The results of the whole thing are stuffed into sum. Then echo out what the current value of sum is and indicate we're at the end of the loop. So we can see that each number is read in as 876, which makes sense because that's what we put into it, 876. And our sum grows up correspondingly. Here's its first value of 8, and then 8 plus 7 is 15, and then 15 plus 6 is 21. So everything looks like it works there. So summing up the numbers in a file that consists of just one number per line. Alright, this is kind of a special case. This is a way to capture data coming in from standard in and dump it into a file. That's really handy. A lot of the commands that we use are ideally situated to work with a file. So for example, the loops that we've been looking at, so I'll go back here, this loop, this sum loop, this is designed to extract data out of a file. So if we can get data into the file, we can use a loop of this type. So in standard in read, we grab data coming in from standard in and stuff it into a file and then do things with it out of that file. So the first thing it does is say cat and then immediately redirects out. So that means that we're not passing in any arguments to cat, which means we're not giving it any input files that it should go open and send to standard out. Since we didn't give it any, cat looks to standard in. Standard in has no data being sent at it, so it just sits at the terminal blinking, waiting for input. So you go through entering in the data that you want, and as you enter in that data and finally hit Control D, it sends an end of file to the standard in. It's read by cat. Cat stops grabbing data from standard in, and then it sends its data to standard out. Meanwhile, standard out has been redirected to a file called temp file. And then the last line of our script is cat out that temp file. So this program then, in a nutshell, captures data from standard in that is sent to this program and dumps it to a file and then displays the contents of that file. Okay? Let's try it. So here's standard in read. I run this thing, and then it immediately starts asking for input. So I type in, I like cheese, and then I hit Control D. Once I do that, it finishes recording the values and then dumps it into a file called temp file, then opens it back up and gets the output, or opens it up, gets the contents, and sends those to standard out. And then it displays that back to us, I like cheese. So we see both of them there. Now, obviously that's kind of a silly usage of it, but this next one shows why this is so cool. I can take this file, so I've got a file called test file, and I can cat test file to get the contents of it. I can then pipe that through, which turns it into standard in. So all of a sudden now, all of the contents of this file are flying in via standard in. They're no longer in a file. Well, this program, standard in read, is able to capture all that data coming from standard in, dump it into a file, and then print it back out to the screen, which is what we see here. We see the printout. Not only can we see the printout in this case, but we now have a file that we could use to do things with. Now the last program we're going to look at is one called TRTest. And the purpose of TRTest is to convert a row file, which means a file that is just numbers on a single line. It's going to convert it into a column file, which is a file that consists of just one number per line, and convert that then back into a row file. So this is just showing you different ways to go from row to column, row to column. That's important for program 1. So let's start this thing out. At the top we've got some header information, some comments that tells what the script does, and then we're going to set up 3 different strings. So these strings look like file names, and they'll be used for file names later, but they start out just as strings. So temp input file, temp call file, temp row file. There they are. Then first thing we'll do is make the input row file. So here's our echo minus e statement. We're going to we're going to output a 1 and then a tab, a 2 and then a tab, 3 tab, 4 tab, and then a 5. Take this whole thing, echo it out to our input file variable. Now this variable, this goes and gets the contents of input file, which contain temp input file as the actual name. That is then created as the file name. So the file is called temp input file, and it now contains 5 numbers separated by tabs. So now we've got our row file built up. It's a file that consists of a single row. So now let's take that thing and convert it into a column file. We're going to do that using a new command called cut. And what cut does is it's able to analyze, it's able to extract columns of data out of a file. So this works because files in Unix are they are fixed width. Every character that's in that file occupies the same width. Unlike something, say, in Microsoft Word, where each individual line has a variable width font. So, for example, if we were using Arial or Times New Roman, something like that, where the kerning is able to bring those letters together to take up less space and make it easier to read, the files in a Unix file, the characters in a Unix file are not kerned together that way. They all occupy a fixed width. So what the cut command does is we can extract a column of characters out of a file. The -C switch says that we want to designate which column we're extracting by character, meaning that the next argument here is the number of the character that we want out. So this works irrespective of what kind of character is there. Let's show the example. So cut -C1 says get me the first character or get me the first column out of the input, and we're going to give it as input file. Now input file is the row file that we've created, and we're going to take the results of this command and create a new file called temp call, or rather create a new file where the name of that is stored inside the temp call variable, which is currently holding the value temp call file. So when I say cut the first column, cut column 1 out of input file, let's take a look at what this file actually contains. And it contains 1, tab 2, tab 3, and on. The first column is 1, so that's the value that gets retrieved, and that's entered as its own line into temp call. Then my next line says, get me the third column from input file. So 1 is the first column, this tab is the second column, the 2 is the third column. So cut the third column means get the 2, and get that from our input file that we'd previously stored, and now append it to temp call. Keep going, and we'll grab the 5th, 7th, and 9th columns, which refer to the numbers 3, 4, and 5 inside our row file, and append each of those to our temp call file. So that works great. This is converting our row into a column file where every line consists of only one number, because that's what append does. It's going to append whatever you give it as a new line on that file. Okay, so one thing to note about cut: this -C works great for extracting characters when we know that the individual columns are logically of fixed width. But if we have fields there, so imagine we've got numbers that could be maybe some of them are 1 digit long, maybe some of them are 4 digits long, maybe some of them are 3 digits long, and they're otherwise separated by tabs. In that case, if we started using the character cut, then we might be grabbing the left part of one column and the right part of the next column. So in that kind of case, we would use instead -F, and that stands for field. And the field operator then is going to look for blank, it's going to look for white space in order to know where to cut from. So up here, when I say 1 tab 2, the white space in between those is 1. The white space is the tab inside, and the -F variant will skip over from 1 to 2, no matter how much white space is there. But since we have a fixed column width and a fixed spacing width, I can use the -C variant in this case. Okay, once this whole thing is done, now all of our file is stored in this single column file, so it's going to be 5 lines, each one with a number on it. Let's convert that thing back into a row file. To do that, first we'll cat out the contents of that file, and that is going to send the contents to standard out. The pipe operator grabs that standard out coming in and redirects it as standard in to the TR function, or to the TR command. And what TR does is it transforms all new lines into tabs. And whatever you put in here is going to be the transformation operator that it does. So it's going to convert all the new lines into tabs for our file. So think about that for a second. If I've got a bunch of new lines in a file, new line, new line, new line, new line, and now each one of those new lines is a tab, now I have number tab, number tab, number tab, number tab, which is back to the row file. So one thing to note, $tempro, that is a variable. That is extracting the contents of a variable. But here I have added $$ to the end. So the actual file name that is created is a concatenation of whatever the contents of tempro are, which are tempro file, concatenated with $, which is the process ID for this script that's running. So this thing is going to look something like tempro file 41612, something like that. When I converted all of the new lines into tabs, this file now does not have a new line at the end of it. And by tradition, by usage, the last character in a standard text file should be a new line, such that when you cat it out, your prompt appears on a new line after that. That's just it just looks a lot better. So because of that, I am going to add a new line to that file here with this echo command. So I say echo append, and I'm appending to it a new line. So I didn't give it any arguments, and that's because, remember, echo always adds a new line. So since I didn't give any argument, the only thing it could do is add a new line to it, which has now been appended to tempro. Alright, well there is our sample program for TRTest. It converts row files into columns and back again, and that should be helpful for you in program 1 and in terms of doing it, in terms of looking at the way that program works and understanding that it's really asking the same thing twice in 2 different directions, and maybe this program will help you do it in one way instead of the other. If you have any questions about these more complicated loops, feel free to talk about it on the discussion board, and we'll see you there. Thanks.